Massey Ferguson's Datatronic II is the most advanced interactive performance monitoring system available on any tractor in the world today. Sophisticated, yes, but at the same time, superbly easy to use. The display is split up into 3 sections. This one shows the memory status, and these 2 are used to display items from the main menu. First of all, the operator decides which display he wishes to alter and presses the corresponding button. When the LED lights up, he presses the button again, and the display shows all the items available from the main menu. He can then scroll down the menu. Engine speed, economy PTO speed, 1000 RPM PTO speed, forward speed, wheel slip, that's actual wheel slip, slip limit. This can be set anywhere from 0 to 99% in steps of 1%. Area per hour is the work rate or productivity. Fuel in litres per hour, that's fuel consumption. Fuel per area, cost per area. Fuel used, area worked, distance travelled, hours worked, and the unit counter, which can be used for counting bales, for example. Comparative mode. We'll come back and look at this more closely in a few moments. External temperature, time, and date. Service tells us when the next one is due. Fuel cost shows the price being paid by the farmer. Cost per hour for operating the tractor. And metric and imperial, which allows all measurements to be converted at the touch of a button.
If we select, say, hours worked, push the selector button and the display returns with hours worked at the top. To reset this figure, simply push the reset button twice and it reverts to 0. This is also possible for fuel used, area worked, distance travelled, the unit counter and service time elapsed. This automatically defaults to 250 hours, which is just right for the engine servicing. If something is reset by mistake and data needs to be re-entered, simply push the appropriate green arrow and scroll up to the number using the rotary knob.
One of Datatronic II's most impressive features is comparative mode, because it can be used to optimize in-field performance. The sequence is simple.
Scroll to comparative mode. Push the selector button again and the comparative mode menu appears, allowing performance comparisons in each of these areas all simultaneously. Engine RPM, PTO 750, PTO 1000, forward speed, wheel slip, cost per area, area per hour, fuel per hour, fuel per area. End is for use when the operator wants to leave the comparative mode. To demonstrate, we'll go to fuel per hour. Scroll to fuel per hour and press the display button. The red flashing light shows that Datatronic II is in comparative mode. Both displays now show fuel per hour. This one is the last recorded value, and this one is the current value of fuel consumption.
As you'll see when I start the engine, the lower panel will be changing with engine speed.
Now, let's continue ploughing. And now that conditions have stabilized, we push the memory button. This transfers the current value to the top. We can now make an operating change. For example, let's increase the throttle setting. Now we can read the difference the change has made in real terms. Here it's about 4 litres per hour. We can then look at productivity, or area per hour, and see that it's gone up by about 0.2 hectares per hour, and then make a decision on whether the improvement is worth the extra cost, which of course we can check by selecting cost per area. With all this comprehensive data, the operator can maximize operating performance for any one or a combination of items.
Now let's look at Datatronic II's memory systems. Datatronic II has 4 separate memories, one for each of 4 drivers, 4 fields, 4 implements, or even 4 farms.
You can record data for area, fuel used, hours worked, distance travelled, implement width, and the unit counter for each of 4 memories, which are selected with these green arrow buttons. And this button switches the selected memory system on and off. To allocate an identification to each memory, you would simply press the top selector button and each of the 10 digits will be highlighted in turn. By turning the rotary knob, you can choose the letter, number or symbol required. Press the button again to move to the next digit and so on, up to 10 characters. Then press the memory button again and it's logged in. Data will be logged automatically whenever the 3-point linkage is lowered or when the timing active button is pressed. This can be used for trailed implements.
All this data can be printed out for further analysis in the farm office. To do this, we simply select the memory to be printed and press the green button a second time. As you can see, there's no need for the printer to be wired in. It works by infrared. Now this also has the additional advantage that one printer can be used for several tractors. And there's the printout. How can Datatronic II help with wheel slip control?
First of all, we need to understand the dynamics of wheel slip. If left uncontrolled, wheel slip caused by a loss of grip reduces forward speed, thus reducing the draft force imposed by the implement on the tractor. In an effort to maintain the draft force, the ELC will instruct the linkage to lower the implement, further increasing wheel slip, and so on until the tractor finally comes to a halt. To see how Datatronic II solves this problem, we return to the main menu to select Wheel Slip, which is the actual wheel slip occurring, and Slip Limit is the limit set by the operator. So, we'll now put each one into the 2 displays. At this point, the slip limit can be reset by using the green arrows and the rotary knob in increments as little as 1%. To activate the system, the operator would simply press the slip control button and then forget about it. He will be told whenever Datatronic II is working with the ELC by the slip control active LED lighting up. This confirms that the linkage is being held to improve the weight transfer, increase traction and reduce wheel slip. With Datatronic II, however, wheel slip control works so quickly and accurately that the operator will not even realize that it's working on his behalf. Under normal conditions, it's the speed of the control rather than the magnitude of the linkage movement which maintains traction as required.
Naturally, apart from general increases in efficiency and reductions in operator fatigue, both tyre wear and soil damage are significantly reduced. Datatronic II also provides the control interface for dual control. Dual control is an extension of the ELC and is only available on Massey Ferguson 8100 series tractors which are fitted with load-sensed hydraulics. As such, it's a completely integrated system which is unique to Massey Ferguson. And it allows the operator total control of long, semi-mounted ploughs, even in the most difficult of conditions.
Without dual control, there are several disadvantages. Firstly, there's the problem of uneven depth of work and poor finish, because when operated in draft control, only the front of the plough moves in response to changes in draft. This is further complicated when a mid-mounted depth wheel is fitted, because when the front of the plough is lifted, the rear of the plough will dig in. Secondly, it's extremely difficult to maintain an even headland line without dual control. This is because, since the rear of the plough reaches the headland later than the front end, the driver requires a high degree of concentration to maintain a reasonable finish. This is even further complicated where the field has an angled headland to the line of work. With the Datatronic II control interface and ELC, all these problems are overcome. Firstly, dual control allows the ELC to control the position of either the rear or mid-mounted depth wheel, so that it moves in unison with the lower links. Any change in draft force will now result in the plough moving constantly in parallel to the ground, maintaining a far more even depth of work, and also improving weight transfer. Additionally, since dual control is a fully integrated system, it's completely compatible with wheel slip control. So, even in adverse conditions, a high level of productivity can still be achieved. The second important benefit is that using this screen, the dual control setting screen of Datatronic II, the operator can program in the effective length of the plough, so that furrow entry and exit is operated automatically. The operator needs only to press the ELC lift control button at the headland. Then, dual control automatically lifts the rear of the plough for him at the required moment. Instead of a severe zigzag finish, angles of work. As the plough turns at the headland, the reading is automatically inversed to compensate for the new angle of the headland. It's well worth reminding customers that the valuable benefits of dual control are unique to Massey Ferguson, because only with a Datatronic II system can the interface be provided with the ELC control system, which makes it all possible.
That briefly outlines the significant benefits of Datatronic II, a unique system which is so far ahead of competitive offerings that it stands alone in providing a genuinely effective interactive system for enhancing profitability. And of course, there's a full explanation and description in the product information guides.